Between setting up your desks, organizing the classroom library, and, learning 20 new names, prepping a brand new science unit at the start of the year can feel totally overwhelming. Welcome to this explainer, designed specifically for RISD second grade teachers to take a little bit of that weight right off your shoulders. If you're gearing up to teach Unit 1, setting up for science, you are absolutely in the right place. My goal today is to get you completely prepped, confident, and excited to teach this 11-session unit, even if you don't consider yourself a science expert at all. We're going to break the curriculum down into bite-sized, actionable pieces so you can walk in ready to inspire those young learners from day one. Today, we're taking a quick teacher-to-teacher journey through 5 key steps. 1. Unit TEKS. 2. Core science concepts. 3. Common misconceptions. 4. Investigations and modifications. And finally, 5. Vocabulary. Let's dive right into Section 1, our destination, the TEKS, and what student mastery actually looks like by the end of these 11 sessions. So, here are our priority TEKS simplified for your daily planning. Across this unit, your kids are going to be doing 4 main things. They'll be asking questions based on observations, planning simple descriptive investigations, actively listening to evidence, and explaining how science actually helps others. It's really all about shifting them from passive listeners to active investigators. To give you a quick idea of what designing solutions looks like at a second grade level, it might be as simple as having them build a small paper shade structure to keep an ice cube from melting. It doesn't have to be overly complex. The goal is literally just to get them actively planning and creating to solve a tangible problem. So what does this actually look like in practice? By the end of the unit, true mastery looks like your students acting as young scientists and engineers. You're going to see them confidently asking questions about the natural world, safely using tools, and organizing their data as evidence. And let's be honest here, a classroom full of engaged second graders mastering these concepts is going to be a little messy and probably a little noisy. Instead of sitting quietly at their desks memorizing facts, they're going to be up, out of their seats, huddled around a table with hand lenses, debating why a toy car moved the way it did. That enthusiastic, slightly chaotic engagement, that is exactly what active mastery looks like. Okay, moving on to Section 2. Now for our foundation, the core science concepts you need to understand to teach this unit confidently. This concept right here is one of the biggest shifts in the unit, contrasting scientists with engineers. Scientists investigate to answer questions like, how far will the car go on a smooth ramp? Engineers, on the other hand, investigate to solve a problem, like, how can I make this car go faster and farther? It's a subtle but really crucial difference. Second graders often struggle with this because developmentally, they just think anyone wearing a lab coat is a scientist. They don't realize that the second they try to fix a problem or build a better ramp, they're actually acting as engineers. Making this distinction clear helps them realize they wear both hats in your classroom. To help guide these investigations, on day 3, you'll introduce a really powerful tool, the CER framework. That stands for Claim, Evidence, and Reasoning. This is your absolute secret weapon for moving kids away from simple yes or no answers, pushing them toward real scientific discourse. First, they make a claim. Then, they summarize specific observations for their evidence. Finally, they use reasoning to explain how that evidence supports the claim. Imagine a student testing different surfaces. Their claim might be, the car went faster on the wood. Their evidence, it traveled 10 inches on the wood, but only 5 on the carpet. And their reasoning, smooth surfaces like wood have less friction, which lets the car move faster. Giving them this exact structure empowers them to communicate like true professionals. Let's look at the roadblocks we might hit in Section 3, clearing up common misconceptions. The big takeaway here is that second graders are highly literal thinkers. They naturally bring everyday colloquial definitions right into the science lab. For example, you'll definitely want to watch out for students thinking the word design just means to draw or decorate with markers and glitter, when in engineering, it means making a structural plan. Another big one is the word model. A 7-year-old hears that word and immediately pictures someone walking down a fashion runway. We have to explicitly teach them that a scientific model is a copy of a real thing that we use for testing. It's completely normal for them to have these language barriers, but reinforcing the academic definitions early on, that will save you guys a massive amount of confusion later in the semester for sure. Moving on to Section 4, let's walk through the hands-on investigations and the crucial modifications you'll use to center equity in your classroom. Day 1 kicks off beautifully with an inspiring STEM connection featuring biochemist Dr. Marie Maynard Daly. She was actually the very first African-American woman to earn a PhD in chemistry in the United States, and she spent her career studying how unhealthy foods cause heart problems. A really fun way to introduce her is to ask your class if they've ever heard the phrase, "you are what you eat."
Let them giggle about turning into a giant slice of pizza, and then explain how Dr. Daly used science to prove how our food actually changes our bodies. Introducing diverse figures like her right out of the gate shows all of your students that they absolutely belong in science.
As we build up to the hands-on work, Day 4 focuses heavily on tools and safety. You'll be showing them things like hot plates, spinning tops, and beakers. It is absolutely vital to ensure they understand proper usage. You might be thinking, wait, why is a simple spinning top grouped with a hot plate for safety? But consider the kinetic energy. A fast-spinning object can easily ricochet off a table and become an unpredictable projectile right near a child's eyes. Setting clear boundaries is key. You'll also need to strictly enforce outdoor safety rules, like wearing proper clothing, taking a first aid kit out with you, and making sure they know to never ever look directly at the sun during field observations. To differentiate and support all your learners, the curriculum suggests 2 fantastic routines for centering equity and access. First, implement a wonder wall, so every student feels safe posting their questions either anonymously or with their name. Second, use listening circles. The mechanics of this are just wonderful for second graders. You have the students sit in a physical circle, often passing a talking piece so only one person speaks at a time. It forces them to practice active listening and gives them a structured way to respectfully disagree using specific sentence stems. This ensures that every single voice, whether they're above grade level, below grade level, or emergent bilinguals, is heard, valued, and given the space to really process everything. Finally, let's unpack our toolkit in Section 5. Vocabulary in the interactive word wall. So, while you have the flexibility to introduce words organically rather than reading from a rigid script, we're going to look at exactly how to utilize the vocabulary lists provided by the curriculum. You can use these to build that vital academic language day by day, weaving it naturally into your lessons as you introduce new concepts to the kids. You're really going to want to heavily emphasize content words like criteria, engineering, and prototype. The curriculum also provides amazing English language proficiency support, including Spanish dual language equivalents like criterios and prototipo. A really fantastic practical tip for your interactive word wall: place the English and Spanish terms side by side and pair them with a simple visual icon or a little sketch that the class agrees on. This visually anchors the meaning and ensures total comprehension for your emergent bilingual students, which lets them participate fully and confidently in those rich CER discussions we talked about earlier. And that brings us to the end of our unit prep. As you walk into your classroom to finalize your setup, I want to leave you with this final thought to ponder. How will you cultivate that crucial sense of wonder in your second grade scientists on day 1? The tools, the teaks, and the safety rules are all there to support one single powerful thing: their natural curiosity. You've got absolutely everything you need to make this a phenomenal experience for them. Have a fantastic time teaching Unit 1.